Hello everyone, welcome back. Today we're actually going to design our own classes. In the last few episodes, we have been using a couple of classes from the Pico library. And today we're actually going to take it to the next level where we design our own class. So let's get started. So last week we looked at this new hardware called the NeoPixel light strip. Basically, the NeoPixel light strips, essentially all of them, have 3 pins. Some of them could have 4. So essentially, the way it works is 2 of the pins are just power and ground, and the third pin is the signal pin. The signal pin is what drives all of the LEDs. Now, typically the way these are designed is each LED has its own controller chip, little tiny chip that controls what color and what intensity that color is shown in. Because they are controlled by their own chips, you don't need to add a resistor to it. In fact, since there are so many LEDs, like the one I'm holding right now has 8 of them. Not just that, most NeoPixel strips that come in this form, they actually allow you to daisy chain them. So for example, you take one NeoPixel strip, attach another to it. They have an in set of pins in the back. So power goes in from here, signal goes in from here. And then there is an out on the other side. So that allows you to take that signal to another NeoPixel strip and so on and so forth. That's how you see all of these LED light shows with hundreds of lights. Now, while that is all good, remember that as you add more lights to it, you will strain the power that comes from this little board. Right now, it's being driven by my USB cable. So the power is actually coming from my computer. So if you go beyond maybe 2 strips or so, it's strongly recommended that you use a separate power supply just for the LEDs, which is pretty simple to do. You basically, instead of connecting the power directly to the Raspberry Pi Pico's power, you connect it to the other power supply. And also you have to connect the ground, to both of them. But anyway, I'm kind of going beyond what is part of this video. So let's get back into it. So what we're going to do today is we're going to create our own class that turns these NeoPixel light strip into some kind of a color wheel, right? So we're going to actually make it spin and let's see how far we can take it today. Again, as usual, for most of these videos in these series, I'm going to try to keep it between 15 to 20 minutes, not more than that. So let's see how much we can get done today. You saw me use this diagram in the last video, but we didn't say how this diagram was created. So I use this tool called Visual Paradigm. What we're going to do is we're going to add a new class to it. Now, we have seen these classes and we have talked about what are the different components to the classes. Today, what we're going to do is create a new class. Let's call it ColorWheel. So every class has multiple components. And as you can see that the components are separated. The top is where you put your attributes. The bottom is where you put your methods. And among the methods, one of the methods is special. It's called init, and that's the constructor. That's how you initialize your class. So what attributes and methods does ColorWheel have? What we're going to do is we're not going to worry too much about attributes other than remember that a color wheel obviously needs a light strip to control. So what we will do is just create an attribute called light strip. Okay. Now, one thing to notice is that light strip is an instance of another class. And when you do that, you're essentially creating an association between color wheel and light strip. So color wheel drives light strip. Now, we're going to go more into the details of associations, but today, just for the sake of this video, to make sure it's complete, we're going to create an association between them. Now, we will talk more about when we get into association, different types of associations. Today, we're going to keep it simple and just connect the two together. And we will just say color wheel drives a light strip. Okay, so this basically just makes that association and just says color wheel drives a light strip. We're not going to talk too much about multiplicity constraints and all of that. That's a topic for another day. So let's think about what methods would it have. Well, obviously it will have an init method, and in Python you have the strange underscore underscore init underscore underscore, and it takes multiple parameters, and we for our methods I'm going to skip the self parameters, but we will talk about that in today's implementation in a little bit. Those are the initialization. What do we need to initialize this color wheel? What we're going to do in this video, we're going to create the light strip separately and then give each color wheel, because as you can imagine, there are multiple color wheels, and they're going to use the same light strip. So although light strip is one class, it can actually drive and large number of these little components. So each color wheel will be using the same strip that we create. We're going to be talking about that. Now, what can a color wheel do? We're going to keep things simple today. We're going to talk more about how these actually works out. But let's just say we will have a method called spin. Um, and we will also have a method called move. So move basically moves a little bit at a time, and spin continuously spins. The difference between them is that move you can sort of control, fine-grained, whereas spin you have no control of. You start the spin and it's going to go on forever, right? So we will have both of them. Now, we'll talk more about how you can, blocking controls and non-blocking controls, but they're definitely not a topic for today. Let's add one more operation. Let's call set color. And spin, set color, of course, will have the color. Spin will have, I don't know, maybe a speed or a delay. Like how, let's talk about speed and delay a little bit. Move, we will say, again, we will, maybe these could also have colors, right? You can spin it or move it in different colors so to get fine grain controls. As it moves, it changes colors. Who knows? You could do so as you can see that as you're designing the class, you can think of how people might be using it. And that's the beauty of object-oriented design, that you can design your classes thinking about how it could be used, not for one specific application that you're doing. You're actually designing something that can be used and reused by different people that maybe you don't even know how they would be using, right? So that's why trying to keep your classes as general as possible is a really good idea. So now that we have a kind of an idea of how we would do this, let's go to the simulator and actually build this thing. So let's go into simulator. So this is what we did last time with the 3 LEDs and one light strip. We're not going to use the LEDs today. So what I'm going to do is add another um, NeoPixel ring. So normally when you create a NeoPixel ring like this, by default it has 16 rings, but you can control it. You can go into diagram and you'll find that number, the pixel ring that you created. And let's change this to only 8. So that way it is just like the other one. And we're going to put that right next to the one that we had. Now, in this version, it's got ground, VCC, which are the power pins. And notice that the input and output are right next to each other. And last time we only used the input pin. To daisy chain, you would basically take the output pin and connect that to the input of the second one. Okay. And then the rest is the same. We're going to connect VCC to the VCC pin here, and we're going to take ground and connect that to the ground. And that's it. That's how you daisy chain. And now we can take this output and connect it to the third one and so forth. Okay, so that's how simple it is to connect multiple light strips. Now let's just test it out to make sure it works. So we're going to create an instance. So we'll say ls equals a light strip, and this is still connected to pin 2. And then let's do a ls.on and pause a little bit and ls.off. So let's see how this works. On, off. So that's basically what it does right now. So, and notice that when it comes on, both of them come on at the same time because we have set it up like that. So now that we have connected the light strips, let's talk about how we are going to build this class. So the way you write your classes in Python is you use the keyword class, and then you give it the name. Ideally, you would want to have lots of documentation, but in order to keep our video short, I'm going to skimp on the documentation. So we'll say def underscore underscore init, and then it will have a self. And let's go back to our design. We'll need a light strip. We need a start, number of LEDs, and color. So we'll need a light strip. We'll need a start. Which LED does it start from? So this light strip, the first one, will go from 0, and it will have 8 LEDs. The second one will start from position 8, and it will have 8 LEDs. And if you go multiple ones, you will have more than that. So num LEDs, and we're not giving any defaults today. We'll just use all of the parameters. And color, so those are my parameters: light strip, start, num LEDs, and color. So these are our parameters. What we will do is we're going to save those in our attributes. So we'll say self dot. What we would do is we're going to be nice, and we're going to put an underscore in front of our attribute names. That would tell other people using our classes that these are supposed to be private. So we will say, and also that way we're going to be able to distinguish our attributes from the parameters that are coming in. So this is our attribute equals. So that one, this is the parameter that came in. We're going to take that and save it into our light strip. All right, so move takes a speed and a color. So def move, again, self the speed. Okay, and for now, I'm just going to say pass here because we don't want to. This one is a little easier, so we're not going to do a pass here. We'll just say self.color equals. What we will do is we can give some defaults here. So we'll just say speed equals 0 for now, and color equals none. And we will change those things as we go along. These are called default parameters. So if you did not specify these parameters, that is what it will take. You will see in a bit how that works out. So what I'm going to do is I'm going to pause the video a little bit and implement the move, and then talk about what I did, so you're not watching me type. All right, so I've written the code, so let's explain it a little bit. It's not a huge amount of code, just a few lines, but since we are starting out, let's explain line by line. One new thing we did was I added a new attribute called current position, or car pause in short. You'll see why we need that, because we need to know which position of the light strip is currently being lit. Okay, now when you start spinning the wheel, we're going to basically light up one LED, then the next time it moves, it'll go to the next one and light that on and turn the previous one off. So we kind of need to remember which one it is that it's currently lit up, right? So when we first start, that current position is not going to be defined. So we will see if it is not defined. So by default, it's set to -1, which is an invalid position. So if it is a valid position, that is, it's greater than or equal to 0, we will turn that pixel off, and you do that by calling the set pixel method of the light strip and change that to black. And then what we do is we take the position, increase the position by 1. In doing so, what might happen that you may get beyond the capacity of this light strip. So we'll need to check for that. So if the current position becomes more than the capacity, how do we know what the capacity is? We take the starting position and add the number of LEDs. That'll give us how far it could go to. If it goes beyond that, what we will do is bring it back to the starting position. And of course, if it's not defined, we'll also give it to the starting position. And then once we get that, we will basically set the pixel to that color. Now, what we did here is if a color was passed in, we'll use that color, right? Otherwise, we will use the default color that is in our attribute. In doing so, there are a couple of things I did. I actually took out the speed from the move. Since move is just moving one LED at a time or one position at a time, it doesn't really make sense to have speed in move. In fact, let's go and make that change in our design. We don't need speed for the move. We only need speed for the spin, right? So that makes a lot more sense. So now let's see how this works out. What we will do is, before we had just created the two wheels, now we're going to test out our move by just calling the two wheels move class, and let's put a delay in here. Time.sleep so we can see 0.2 seconds. Okay. Now we're going to run this and see if our LEDs move. So let's run it. And there you go. Looks like the low brightness makes it kind of hard to see. So we'll put it full brightness. Let's run it again. There, lot easier to see. Now you can see our wheels are moving, and we can kind of control the speed. Let's change it down to 0.1. And now it should move a lot faster. And if we change it to even less than that, it's spinning really fast now, right? So that's basically how our LEDs move. And that's essentially what our color wheel is. Now, let's talk a little bit about blocking code. Remember, how did we make this LED spin? We're basically using this while true, which basically means that forever do this. Forever, we're going to spin, move the first wheel, move the second wheel, and then stop a little bit. So when we are implementing the speed, the spin, we could do it like that. We basically move for a little bit and sleep for however long we asked it to. Now watch what happens. Let's say I want both wheels to spin. I could say wheel 1 dot spin, and let's say 0.05, so it's pretty fast. So that's the speed it's going at. And we could also do wheel 2 dot spin. Now, what you will see is something interesting. What we're expecting is wheel 1 spins and then wheel 2 spins, right? But when you run it, you'll see only wheel 1 spins. Why? Because the spin is called a blocking code. It has this while true which never finishes. So we call wheel 1 dot spin, and we are in wheel 1 dot spin, and we are basically going to be stuck here forever. So spin, at least for now, is a blocking design. So we would, in order to have parallel spinning of two wheels, we're going to have to use the move method to change something. So since we have done all this, let's just run it on our hardware and see how that works. And well, let's just run it with just seeing one wheel spin. So let's run this. And now you can see only this guy is spinning, nothing's happening on that one. We expected that, right? So what we're going to do is we're going to go back to the previous version that we had. where we didn't call spin, we instead did, now we will see both of our wheels spin. So let's give this a shot. There you go. Our first wheel is spinning blue, the second wheel is spinning red. Isn't that cool? And that's how you create your own classes. We did run into some little interesting things today, and that's basically the learning process of Python. Hope you enjoyed this video, and we will see you in the next one.